Hello and welcome to another reverse engineering video. In this one we'll be looking at Flare 2020 competition challenge number 6, which was called codeit. So as usual we do get our node, and this time it reads reverse engineer this little compiled script to figure out what you need to do to make it give you the flag as a QR code. And I guess the challenge name, codeit, and this little compiled script or compiled script was an indication that this is AutoIt script, but to be honest that wasn't really clear to me when I was doing this challenge, so I had to figure it out. And what I did was to actually run file command on the executable, and then it says it's UPX compress, so of course we can decompress the file. If we run it on a decompress, it doesn't say really much, it just says okay, MS Windows executable. But if we load it to Ghidra and if we go through the strings, we can actually find some strings that indicates that this is AutoIt script. They are not that obvious right now, but I guess if we filter, there are some AutoIt version 3, AutoIt executable script, and some other strings that can indicate that, and that was an indication for me that this is AutoIt script, so we will not be using Ghidra in this video. What we can use from this Flare VM, we can use AutoIt Extractor. There is a tool to extract source code from those scripts, and it will quite nicely extract the source code of this script. So that was the first part of the challenge, to extract the source code. As the second part, so since we have the code, it actually looks like this. So it's not very nice, it's of course obfuscated, but if we look around we can see a few things. One is this huge chunk of data which we can see near the end of the file, and it actually being splitted by this 4FD5 and the $sign and put into this OS array. And we can also see a lot of usages of this OS with different other variables names. Well, actually here is, it's different. So we can see some usages of this huge array, but we don't know what actually is here. We can suspect there's some kind of string. Looking at those values, they look like ASCII printable characters if we treat those as a hex. But how can we find out if it's really what's really being done with it? And actually it's this function that being decoding those strings, and it actually is just converting from hex. So we actually extracting 2 characters at a time from this array, and we convert it to decimal and then convert it to character. So we can actually write the same in Python. So we have this big data here, we are splitting by this magic value, and then we convert it from hex to actually strings. We can print it, and then I just wrote a little short script to actually, I can provide an index and then print string that is basically under this index, and it's being helpful for those usages, because this is actually, if we search this, we'll see that this is actually a number being set in this odd way, type number with a value 25. So this is 25, and if we run our script, this is the whole table of strings, and I can provide this index. I don't know why I wrote 3, because I wanted 25. So I can write 25, and it's kernel 32 DLL. So basically in the place where we have this string being used, it's kernel 32. And slowly we can rebuild the original source code without this obfuscation by replacing the usages of this OS array with indexes along the whole source code. And actually this is what I did. So I reconstructed a lot of the code, maybe not all because I didn't needed it all, but this is reconstructed source code. We can see actually this is the array with all the strings. This is hex to string function, and you can see, okay, we have some usages of kernel32, uint, set file pointer, and this is basically DLL calls. So we can specify in, I guess in AutoIt, I don't know it that much, but we can specify a DLL call. We provide a DLL name. I guess this is a return type, function name, and some parameters to the call we provide. Also, there's a lot of like DLL structure create and DLL structure manipulation in this script. So we can define, okay, this is the struct that is actually just contain a dword argument, and we can pass it then to, I guess, this DLL call read file. It's passed here, and we will just read 4 bytes from read file with the handle. Yeah, with the handle that's, I guess, specified a file. Okay, so having this source code, we need to find out what actually can give us this QR code and give us the flag. And we can see this QR encoder DLL that it's also being used in by this program. We can see it's being used a few times with DLL calls. But yeah, how to find out what actually is needed to get the flag. We can also see some cryptographic functions being called, like crypt hash and get data. And here we can also see some flare data, which actually might indicate that, okay, we are getting closer with the flag. But there was one particular thing that was quite interesting when I was looking through this binary, and it's, do I have the backmark? Yes. So was this get computer file name function, which of course calls this function and returns a computer name of the machine. That was quite interesting, because why we would need to query for that information if not for some kind of confirmation that we can get a flag. And this is used here in this function. No, not in this function. It's used in this function where I call it check for correct flag, because it actually checks for the correct flag. And after we get the computer name, we created some structures, and we actually generate a hash of that data, and if the hash matches some magic values here, we will pass correct values to the binary, and we will probably get the flag, because we don't know since we haven't really run it. But that was the point where I started looking into how we can get the correct data and what should be this computer name to actually allow us to get the correct flag. And the more interesting was in this manipulate computer name data function. If we go there, it's quite strange at first, because okay, we are getting the computer name information, but then we open a DLL or BMP file, because this function was basically returning either of those two. And then after opening this file, we read some data and we do some looping and some comparing. So that was actually quite strange, at least at first when I saw this code. And what's actually happening here when we get all those information together is that we load the sprite BMP file, we read the structure, and the structure is just basically the whole file. Then we create a structure for the header of the file, so basically for the BMP file header, and we read that data. And when we get this data, we convert it to from binary to numbers, and of course from numbers we can get characters. And how we convert it is here. So basically we loop through the bytes from the highest bit to the lowest, and we do some bit end and bit shifting with those values that we have here. So basically we convert the values that we see in this file with this construction that we see here. So basically convert the values from the file to some printable potentially characters. And we can see actually how the file looks like if we just find the file. So this is the file sprite BMP, and let me try to open it. Okay, but that's not the best opening because I don't want to see the file. I just want to see it in an editor. So here is this strange data that we actually are interested in. So we see it's like FF, so it's kind of very, how to call it, not random, and based on that code and this data we can extract some information. So what I did was actually just have some name, open the file. This is the original code. I just transferred it one-to-one. Don't even try to optimize to have it in more Pythonic way. Of course there was some printing in between to be sure that it works the same, and at the end we just print whatever we managed to extract. And remember that whatever we get, we will be comparing with the computer name to go further and get the flag. So let's see what actually prints. So if we run it, of course not Python 2 but Python 3, and it prints AutoIt fan 1999. So that should be the computer name of our machine. So let's just go back to our Flare VM, and actually I did set it as actually it's username. Sorry, it was not computer name, but it was username. Actually this is computer name, and then Flare was the username, and the username was actually checked later in the source code. There was this Flare string added to the computer name. I think this is kind of it, but okay, but that was my mistake. So the computer name is autofan, and then Flare was the username, and with that we should pass all those checks because the hashes will be the same. So we can actually run the binary now and get the flag. So let's just sorry, what was it was codeit. Okay, and then we just need to write anything and we'll get the QR code. And the funny thing is that no actually online program wanted to give me the flag from this QR code, so I thought it's maybe broken, but actually my phone works. So and when I just scan it with my phone, I got a flag which looks like you didn't run auto time on this one at Flare on com, and that was the flag for this challenge. So yeah, actually quite nice challenge. A bit of manual work maybe with this source code, getting some kind of something we can reason about, but nonetheless, yeah, we were managed to get the flag. And yeah, that's it for this one. I hope you like it, and if so, please like and subscribe, and see you in the next reverse engineering video. Bye bye.